If you get anything out of this video, it should be what I'm about to say. In this video, we're going to talk about what factors affect the time that an object spends in the air during projectile motion. So what factors affect how long it takes an object once it's launched to fly through the air and fall back to the ground. The key is that in a projectile motion problem, while this object is flying through the air, the only force acting on it is gravity. Gravity acts downwards towards the earth. The force of gravity accelerates an object down towards the ground. As the object is flying through the air, gravity is always acting on the object, so the vertical acceleration of the object at any point during its flight is always pointed down towards the ground. So the object always has the same vertical acceleration. An acceleration is a change in speed or a change in direction. This acceleration, which for an object flying through the air is equal to g, the acceleration due to gravity, is going to change the vertical component of the speed of the object,
and it is going to change the direction of the object's motion.
If an object is projected at an angle or launched at an angle, it's going to have a horizontal component of a speed and a vertical component to its speed. The acceleration due to gravity is only going to change the vertical component of the speed. So as the thing flies through the air, the vertical component is going to change. I talked about this a lot in the first video. So if this doesn't make a lot of sense, watch the first video, it explains these arrows more. So the vertical component of the speed is changing as the object flies. That is caused by the acceleration due to gravity, which is pointed in the vertical direction, which is why it changes only the vertical component of the speed. Not only does the acceleration due to gravity change the speed of the object, it also changes the direction. If we only talk about vertical stuff, first it's moving up, then it turns around and comes back down. It is the force of gravity that causes the object to fall back down to the ground. The force of gravity acting vertically is the only thing
causing the object to fall to the ground.
The key is that only vertical stuff is going to affect the time that the object spends in the air. So how long it takes an object to come back down and hit the ground is determined only by vertical stuff, because the only stuff that's changing is vertical stuff. There's a force acting only in the vertical direction and an acceleration only vertically. Well, horizontal stuff has absolutely no effect on the time that an object spends in the air. There is no force acting in the horizontal direction to change anything. Whatever speed the object has horizontally at the beginning, it is going to maintain that horizontal speed as it's flying. If there was no force of gravity, there would be nothing to change the motion of the object, and it would go to the right forever. So horizontal stuff, the initial horizontal speed has absolutely no effect on how long the object stays in the air. It is vertical stuff, the initial vertical speed, initial height, the acceleration due to gravity, which is a vertical acceleration, that determines how long the object is in the air. Horizontal stuff does not affect time. Vertical stuff determines how long the object is in the air. So let's talk about how launch angle affects time. So each ball had a different launch angle in this case. Let's compare the times that each of the three balls were in the air and see how the different launch angles affected that time. The purple line represents ball 1, the red line ball 2, and the orange line is ball 3. We can say that T3 is greater than T2, is greater than T1. So the higher the launch angle, the greater the time spent in the air. Why? The greater the launch angle, the greater the vertical component of the speed. If it has a bigger vertical speed, it's going to go higher in the air, which is going to give it more time spent in the air. The higher it goes, the longer it's going to spend in the air. Right? So if the orange ball goes up the highest, it's going to have the furthest to fall back to the ground. It goes up higher and then it has to fall down further than any of the other balls. So it's going to take longer to fall that farther distance to the ground, which is why the higher the ball goes, the longer it's going to spend in the air. And what determines how high the ball goes? Well, the vertical component of the speed. The more speed you have pointed in the vertical direction, the higher the ball is going to go, which in this specific case depends on our launch angle. The greater the launch angle, the greater the vertical component of the speed, the higher the ball is going to go, which means the longer the ball is going to spend in the air. Notice I'm only talking about vertical stuff, like initial vertical speed and height. Remember, horizontal stuff, like the horizontal component of the speed, has no effect on the time. The reason that the ball with the middle launch angle goes a farther horizontal distance than the ball with the smallest launch angle, even though the horizontal component of the speed of the second ball is smaller than of the first ball, is because the second ball, this red one, spends more time in the air. Remember, the horizontal component of the speed has no effect on the time spent in the air. The second ball has a smaller horizontal component of the speed than the first ball, but it has a greater vertical component, which means that the second ball is going to go higher, which means it is going to spend more time in the air than the first ball. So it's going to have more time to travel horizontally. The second ball is going to spend more time in the air than the first ball, which means it's going to have more time to travel horizontally, and it's going to be able to cover more distance horizontally, even though it's going slower horizontally than the first ball. The first ball is traveling faster horizontally, but because it has such a small vertical component of the speed, it's going to spend very little time in the air. It's going to hit the ground before it has much time to cover any horizontal distance. But this second ball is going to keep chugging along to the right with its horizontal component of the speed for quite a while before it hits the ground, which is why it travels farther. Does that mean that the object that goes the highest vertically is always going to go the farthest horizontally? No, not necessarily. And the ball with the biggest launch angle, so you might be thinking, oh, maybe because it has such a large vertical component, it goes up so high and it has a ton of time to travel to the right and cover all this horizontal distance, so maybe this one should be the one that goes the farthest. Well, that's not necessarily the case, because the vertical component of this one over here is so large, the horizontal component is so small, that even though it spends a lot of time in the air, it's moving so slow horizontally that it's still not going to be able to cover a ton of distance horizontally. Now let's talk about how initial speed affects the time spent in the air. They all have the same launch angle, but different starting speeds. If the total initial speed is greater, the components, the horizontal and vertical components, are going to be greater. So the one with the greatest speed had the greatest vertical component of the speed, so went the highest, which means the one with the greatest speed is going to spend the most time in the air. So remember, we said the higher the ball goes, the longer it's going to spend in the air, right? Well, really, we don't care about the horizontal component. Again, the horizontal component of the speed does not affect the time spent in the air. It is the vertical component of the speed that we care about. The bigger the vertical component of the speed, the higher the ball is going to go, the more time it's going to spend in the air. So the greater the vertical component of the initial speed, the greater time the ball is going to spend in the air. Okay, how does the initial starting height affect the time spent in the air? The higher the ball starts, the greater its maximum height is going to be above the ground, and it is going to have more time in the air because it has to fall farther to get back down to the ground. The ball with the highest starting height also spends the greatest amount of time in the air. And finally, which ball has the greatest vertical speed at the end? Well, that depends on the time spent in the air. So the ball that starts the highest spends the most time in the air. If it spends more time in the air, it's going to have more time to accelerate down to the ground and to get to a faster speed. and it's accelerating in the vertical direction. Its vertical speed is getting faster and faster and faster as it falls to the ground, and because it has more time to do that, its vertical speed is going to be the greatest out of these three. And finally, I want to compare the final speeds of each ball. We compared the final vertical components of the speed. What about the total speed? So now we're talking about both the x and y components of the speed together, the total speed. Remember, they all start with the same initial speed at the same launch angle. What does that mean? The x components of their speeds are all the same. So they all start out with the same horizontal speed. They keep that speed throughout their flight because nothing is changing the horizontal speed. So if we're comparing the final velocities at the end, well, we know they all have the same x component of the speed, but we can't just look at one component. We got to look at both the x and y components if we're talking about the total speed, because the total speed is at an angle, so it has both an x and y component. So the one that has the greatest vertical speed is going to have the greatest total speed. The x components are the same, but because they have different vertical speeds at the end, they have different speeds at the end. So we can use the vertical components to compare their total speeds, since their horizontal components are the same. And the one with the greatest vertical component has the greatest total speed. One with the smallest vertical component has the smallest speed at the end. What about mass? Does the mass affect the time that an object spends in the air when it's in projectile motion? Well, the force of gravity accelerates all objects with the same acceleration. So every object flying through the air on Earth has the exact same vertical acceleration. The acceleration due to gravity, 9.8 meters per second squared. So no matter what the mass is, how heavy, how light an object is, they're all going to have the same vertical acceleration when they're flying through the air, which means that the mass has absolutely no effect on the time that the object spends in the air. So if you launched a ping pong ball and a bowling ball at the same launch angle, the same starting height, and gave them the same initial speed, their masses are different, but they would spend the exact same amount of time in the air because the mass does not matter. Okay, if you made it this far, here's a list of what does and doesn't affect time. So we learned that the launch angle, the initial vertical speed, and the starting height all affect the time that an object spends in the air. Now, what does not affect the time? Well, horizontal stuff does not affect the time spent in the air. So initial horizontal speed does not affect the time spent in the air. And neither does the mass. The mass does not affect the time.